All right, so today we need to fill in what all these blanks. It says a function can be thought of as a machine. Look, it's magic. And what do we know about functions in regards to x and y?
X is the independent variable,
Mm-hmm.
and then Y is
Yep, and what does every independent variable have to have? What does every x have to have in a function? How many y's? Fantastic. So it assigns one input to every output. So when we did the LTF lesson, remember you guys had a problem that said find the function when the hours are 11. And we had to plug it in, and then some people divided by 7, and some people divided by craziness. So what we're going to learn today is how to actually plug it into this so that you get an answer out. Is everybody ready? You writing me a sticky? Okay. All right, so this guy right here, the arrow's pointing at F. That is the name of the function, and we can name them different things. Name of the function. So if we have more than one function, we could call one f at x, and we could call the next one g at x, or hello, or h at x, or baby Jesus at x, or Oreos at x. Whatever this guy is out here, that's the name of the function. Now, x. Where else do we see an x in our problem? Over here. And what would we do if I put a number here?
Put it where the other x is.
Yes. So, this guy tells what number to plug into the function. You guys do know that if you interacted with me more, you wouldn't look as bored or like you want to jump out the window. Just throwing that out there.
Whoa.
All right, so how do we say this? Who remembers how we say this whole thing right here? F at x, and what does that mean?
F is the function of X.
Yes, yes. All right, so f at x means Blair. F is a function of x, and haven't we said that before?
Yes.
We've said those words before. So is f the independent variable or the dependent variable? Who remembers?
Dependent.
Dependent. And so what is x?
The independent.
The independent. And does anybody else know what this whole thing is called? It's a machine. And what axis does it lie on?
I mean, the X. Both.
The X. It doesn't lie on any axis. It's on 0, 0.
What's the function?
What axis does this lie on?
Oh, the independent?
The Y axis.
The Y axis. Are you talking about the whole thing? I'm kind of confused.
This guy right here. This whole thing. What else is he called? Which axis is he?
Independent, so it's x.
The whole thing, like F.
This
F
whole
and
thing.
X.
This whole thing right here.
It's a trick
Oh,
question
that whole
because
thing?
the f is the y. Isn't it?
That's our Y.
Yeah, it's
that's
a
the-
trick question.
It's not a trick question.
The f is the y, so it's gonna be on the y.
It's the Y axis.
and the x is gonna be on the x axis.
But it would be this X over here.
No.
So this whole thing is our Y axis. It's also called, well, it kind of is a trick question. That's a good point.
Wait, so if the x came first, it'd be the x axis.
Oh, crap.
No, because we could, yeah, we would never call it X at X. The function would never be named X. All right, so it is also called Y. And you guys remember we had an LTF problem that said that. I think it was like G at X or something crazy. And it said name the one N and then name the Y axis G at N. We had that. So f at x is also y. It's your y axis. That is your output. And this guy right here with his upside down mustache, he is the function. The function. So this guy is our machine, and we plug into the machine. And after we plug into the machine and the machine does its job, then we get this guy.
Sorry if I can't spell.
I'm sorry.
It's okay.
Are we ready?
Okay.
Why you say no? Just to be contrary?
I'm ready.
Are you sure? Okay, so read the directions for me, please.
Find and illustrate f at 2 and f at -1 using the function machine below.
Okay, so we're going to use our function up here. We're going to use this guy, and we're going to plug in 2, and we're going to plug in -1. Is
Does
everybody?
it look like that?
Because this is the machine. I know. I love it so much. All right, so we're going to plug in 2 into our machine. And our machine is f at 2 equals. And what is the machine? What is the function?
3x plus 4.
Yes, so where would we put the 2?
And that.
Yes, so 3 times 2 plus 4. So this guy is our function. He's the machine. You write him in here and you plug in x where you see an x. So what's 3 times 2?
6.
And what's 6 plus 4?
10.
Look at that. That's our output. So f at 2 equals 10. And so this, like, you know, we don't have to draw our machine every time. It's just a fun way to think about it and make it pretty.
Someone do that.
We are. I want you guys. Okay, so you guys are going to do -1. And I'm going to write f at -1 equals. You guys plug him into the machine and get an output. Don't yell it out. Just do it on your own. No screaming.
Wait, so f is 3?
F at -1.
Where'd you get the 3 from the last time?
The problem. All right, are we good?
See.
So did you guys write 3 times -1 plus 4?
Yeah.
Okay. And then did you do 3 times -1 as -3? And then -3 plus 4 gives you 1. So f at -1 equals 1. That's all you got to do. Isn't it magic? It doesn't. That's all you do. Your function can get more complicated. Like we could put an x squared or something like that in there. But you just do the same thing every single time. That's it. That's all we do. It's so easy. Lemon squeezy.
She likes to eat the whole one.
There's gonna be a thing that we have to figure out what F is.
That's what we're doing. F at -1 is 1. So y equals 1 when x is -1.
So what does this have anything to do with graphing?
Because if this is our x value and we plug it into our function, that gives us our y value, and then we plot these on a graph. That is a great question.
So all graphs we gotta make, you gonna give it to us, right?
Yes. Yeah. I won't make you draw. I mean, like, you'll have graph paper,
Yeah. Okay.
but I won't make you draw it on like a number paper.
Okay.
All right, now please open to the inside. Open to the inside. Open to the inside.
Why are there so many parentheses?
I'm gonna show you. How about we just calm down because I haven't explained anything. Tater. Okay, so in this first machine, we're gonna put f at x, and I'm gonna use green for him. So f at x equals x squared plus 3. Which one do you think we're gonna put in the bottom one?
Wait.
Okay. G at x, yes. All right, so in this guy, we're going to plug in g at x. I'm just writing the functions into the machine. How's that going too fast?
Going too fast, Gary.
Oh my gosh. I haven't even done any math yet.
you not write equal after fx?
You can.
Okay.
Okay, I'm ready.
Gracias.
Too much.
Maybe.
So,
Maybe one day.
is it Paul's?
Yes, you are. All right, so the first one says f at 3. So are we going to plug it into the green function or the
Yes.
pink function?
The green.
The green function. So it says f at 3 equals 3 squared plus 3.
I'm gonna use
And then what's 3 squared?
9.
And what's 9 plus 3?
12.
Boom, we're done. So when x equals 3, y equals 12. Boom, we're done.
Phrasing.
Do we have to?
Can we just write 12
Let me go back to
Write everything. We are.
3.
All right, so are we going to plug this guy into the pink function or the green function?
pink.
The pink function. So we're going to do 3 plus 1, which is what?
5.
4. 4.
That's all we do. So you guys want to take a moment and do the next two?
Yes.
So do those real quick, then we'll come back and do the fifth one together. Not out loud, Tater.
Whoa.
Negative 2 squared is not negative 4. Remember, watch which function you plug it into and watch your positives and negatives.
Oh man, that's what it says though.
And put it in
Oh,
parentheses.
Yeah. Okay, this one. 3. Oh, why are we doing conjoined ones, man? Right.
It's not any different. Whiny, whiny babies.
Ooh, I think I have these.
Are we done with those two? Yeah, y'all can go ahead and work ahead of me.
I'm gonna try because I'm writing in pen. I'm scared.
Yeah, you can work ahead of me. Write it in pencil first then, Tater. Look at me solving these problems.
I think I have to go back.
Oh my gosh. Did everybody get 7 and 1?
Yes.
All right. I'm going to give you a minute to work out the next. You don't stop clicking that pen.
I am so dumb. I cannot.
You're not dumb.
Well, I said 0 plus 1 equals 0, so.
Well, okay.
Just a little bit.
You're not dumb. You're just not paying attention to what you're doing. How about that?
There we go.
That's nicer.
Oh, frick.
Did you get it?
Oh my god. I'm gonna Pokemon right.
Did you guys get 9?
Yeah.
Yay! All right, do the next one without me.
Damn, okay, after the next one, you don't have to. Right.
Yeah.
For this one?
For you.
Okay, so all you have to do on this one
Oh,
is. Oh, okay.
What do you do with the Y?
Okay.
Yeah, what about the one with the Y?
With the Y,
Yeah,
plug in the letter.
there's.
Just like we did the last time, and it was just a letter and a number.
Oh.
Just plug in the letter.
It's not a number, it's just.
So
I'm
it'd
talking to
be
them
F-
still.
F squared plus 3 would just be the answer.
It would be y squared plus 3.
Oh, yeah, Y squared plus
Yeah,
It smells like tricks in here.
I'll do what I can.
Oh, that could go both ways.
I know. It's recording.
I'm gonna go back and watch, but I want to show my mom how this got. She's gonna be so confused.
I do not want to do this.
All right, so on this one, is everybody ready for this next one?
Yes.
Has anybody tried it?
No.
Doesn't it say G at 2 first inside? So don't you think you should plug in 2 into G at X?
Oh, and then your answer from that.
You plug into F. Yes. So all you do is you take what you get for G at 2 and plug it into F at X. It's magic. So you, okay. So if we plug in 2 right here, what's 2 plus 1? 3. And then you take 3 and you plug it in here.
I got it.
And yes, you're right. Yay. Aren't these fun?
Sure.
I love them. I know.
You get to the hard.
You get 12.
Yes. All right, so finish them on your own. Finish the next page. Keep working now. That way you don't have homework this weekend. Monday, we're going to pull everything together. We're going to match up stuff with relations. We're going to determine if a relation is a function, and then we're going to plug that function into the machine and graph it. Get excited.